Hello and welcome to this video where I'm going to demonstrate some of the features of Papertoy, the tool or game where you can create card games quite easily in a language that I developed called Paperlang. What you can see here is the sort of the absolute minimum you need for a game. There's nothing in this game. And eventually what's planned is to move all of this code into the editor so that you can actually define all the game logic yourself graphically and not have to type anything. So as you can see, we have this number of players 1. That just means the number of players is 1 in the game. We can have this as 2 or 3 or 4. At the moment it's always going to have this opponent and you here because that's what the default is at the moment, but we can have just one player, and you can see that we have this setup and turn blocks here. So what this means is everything between the start and end words here is going to run at setup at the start of the game, and everything between the start and end words here is going to run each turn. So this is going to be, you're going to say what happens every turn here, and you're going to say what happens at the start of the game here. So this is all well and good, but there are no cards yet, so let's define some. So what I'm going to do is define a color card, and the way you create a card is by doing this. So say you wanted to create a game where you were battling monsters. So if there was like you'd have a type of card that would be a monster, like this, and in here you would have all the attributes for the monster, like health. Int just means integer, it's just a number, and maybe you'd have strength as well here, which would also be an integer, which is just a number, a whole number. But as we're just going for color cards, we don't need any attributes at all, so we're not going to define any. And we can actually put the end word here on the same line as the start, just to save space. And so now we've got sort of our kind of card. You're going to see why this is important later to define this first. We now can make some colors. So we have a card here, a red card, start and blue card. And these can all have attributes too, just like the type can, but we don't need to define them here for colors, so we won't for this demonstration. And card yellow, start, end, card, let's see, cyan, start, end, and purple, and magenta. Okay, so I'm going to press R to reload. You didn't see anything happen because we actually haven't added anything that's going to display yet at all. So in order to add something that's going to display, we need to add a stack of cards. These cards exist. These cards are now defined in the game. They exist in the game, but they're not displaying on the screen. And to display something on the screen, we need a stack. So in Papertoy, there's a concept of a stack. There are two kinds of stacks right now. There is a hidden stack, and we're going to name that A, and there's a visible stack, and we're going to name that visible stack B. It doesn't matter what these names are. We can name these Joe and Tom. We're going to name them A and B. So hidden stack, all of the cards are face down in a pile, and in a visible stack, the top card is flipped up, is visible to you. So we're still not going to be able to see if I press R. You still can't see them because there are no cards in these stacks. So what we're going to do is we're going to add cards to them. So now you'll see why it's important that we defined this color here. And we forgot something. We forgot to say that all of these cards are of type color. So blue is a color, red's a color. We're just going to copy this and paste it all here. So all of these cards are of type color. So we define this color and we say red, it's a color, and here are all the attributes if we added any. Even if we're not adding any attributes, again, it's important to have these start and end tags here. So in order to show these stacks on the screen, we need to add cards to them. So we can go move random color to A and move 10 of them. Ignore this right now, this top tag. It's not actually necessary for the random move, so it's going to be removed soon, but you'll see what it is necessary for later. It's just I haven't got around to removing the need for this when you're doing a random move. So so this is in the setup, because this is going to run once to the start of the game. You'll be able to see this is the A stack, and there are 10 cards in it. You can actually count these ridges, and you count that there are 10 of them. So we're also going to move random color to the B, and we're going to move 5 of them so you can see the difference. And you can see that because B is visible, the top card is showing. Now, we have 2 stacks, so what can we do with them? Well, so every turn, something is going to run in here. What we can do is we can move cards between stacks. So let's say every turn, I want to move a card from the visible from stack A hidden to stack B where it's showing to the top. So in that case, we can go A, move to B, top 1. And that's going to move the top card in A to the top of stack B here. We could move it to the bottom of stack B by putting an underscore here. It's like a move underneath, right? That's the idea there. And the top means that we're going to move the top 1 cards from A into B, and that's why this top is necessary in a stack move. We could also say bottom if we wanted to. We're going to say top. So let's do that. Let's reload the game like that, and let's press space, because that runs a turn, should have said. And as you see there, we moved the top card from A onto the top of B, like that. And we can keep doing this until A is actually empty, and then it just won't do anything. It won't error or anything. If nothing's available from A, it just won't move anything. And you can see the turn marker here going up as we press space. But we can reset that. And every time we reset, you can see that we get another random. This indeed is random. We get a random 1 at the top. We can move 1, or we can move 2 as well. If we press R here, we actually move 2 there, even though it didn't look like it. But we're just going to stick to 1 because that's a glitch, I think. So yeah, you can see it moves 1 every time. But you can move 2. It's just the animation looks a bit funky right now. If that's a bug, I'll fix that. So this is a bit boring. Why don't we turn this into a game? And I want to make a Snap game, because Snap is just the easiest game to make. It's a really simple game. So you just keep placing cards until you match the one below it, right? So color Snap, we're going to call this. So Snap, if you haven't played Snap, it's usually a 2-player game, and one player draws a card and places it on the pile, and the next player draws a card, places it on the pile, and if at any point the card you place matches the card below it, you win, or the player who placed it wins. So we're going to create one player Snap right now, and to do that we're going to have to introduce like a different slightly different concept, but it's going to be fine. So we're going to rename these. We're going to rename these stacks. The hidden stack is going to be the draw stack, and the visible stack is going to be in play with a lowercase p. And we're not going to bother moving anything into the. Well, actually, let's rename these first. So hidden stack is A. Which is draw now, and visible stack is B, which is in play now. So let's just change all of these from A to A, from their previous names into their new names. And now let's also say we don't need, at the start, we don't need any cards at all in the in play stack, so we cannot do that. And this is what's called a comment. If you put a hash at the start of a line, the game won't process anything. So you can say hash blah blah blah. So you can use it for notes. In code, this is called adding a comment, and you can use this for notes. Like this is a comment. it won't be processed by the game, right? So you can put a comment in front of a comment marker in front of any line of code, and that line of code will no longer be processed. We can just get rid of it, but I was just wanted to demonstrate that you could do that. So now there's only one stack visible. The other stack is here. It's just there are no cards in it. And it's only when you start playing your turns that cards will go into that pile. Okay, reset that. So now we are moving cards from the draw into the in play. But how do we check what the card below the one that you've just placed is? So you can, and how do we then say, okay, if it matches, then I win, right? Because that's what we want to say, right? So what we can do is we can use what's called an if statement. So you can say if end, no, not end, if start, end. And the condition you're going to write here, and then what happens if the condition is true is going to happen between the start and end tags here. So what we're going to check, we're going to check in play dot, and this dot just means we're going to check a property of in play, right? So in play dot top is this means the top card of the in play stack. We're going to check if that is equal to, now in programming, the double equal sign means equal to, so to test equality. So if this card matches in play.top -1, and this just means the top card underneath, one below the top card. So you could say top card -0, and that would just be, and this would equal this all the time, right? Because the top card -0 is the top card, but the top card -1 is the card below it. And if there's just one card in the stack, this will just not be equal to true. This will not equal this. If top -1 is nothing, it won't be equal to top, and it won't error out or anything like that. At least I hope it won't, because that would be bad for this demonstration. So if that's the case, we're going to say we need to declare a winner. Winner is, which is just one word, and then current player, and that just means current player is always the player whose turn it is now, and that's all it is. So we can refresh, and we're going to start playing. So hopefully we'll reach the win condition before we reach the end of the deck. But so magenta, red, hey, there we go. So you see a blue on the top of a blue, and that's a victory. So we won. We can do that again. So reset, yellow, blue, magenta, blue, yellow, purple, blue, purple, magenta, cyan. Oh no, we ran out. So we can actually run out of cards before that happens. If you wanted to, we could say add a random color every time, but I don't think that would look very good. So I think I'm just going to add 20 cards here. The limit to how many cards you can show is actually 10, because otherwise it just sticks out. It ends up sticking out all the way. I might do something different where we make sort of a visual indicator that there are more than 10, but if you have more than 10, it just looks the same as 10 in the stack. So let's do that again. Cyan, red, yellow, cyan, blue, yellow. There we go, cyan, cyan. So, and we won again. So let's make this 10 again. Right, so we have this one-player game. It's like solitaire, right? So it's the most boring solitaire in the world, because you're just moving cards from one stack to another, and then you win or you lose, depending on how far you get. We could also say if in play dot size equals 0, and we could also say loser is current player, which means just you lose. Like, no one actually wins, you just lose. It's a way of declaring like that you've lost even in a game where there's only one person. But we want to do something different. So we want to actually make this 2 players now. So to start with, we want to play 2-player snap. To start with, I'm going to make 2 players like this, and now this will actually be 2 players now, but it won't look like it, so you'll end up having defeats sometimes depending on who wins, right? So I won that time, but maybe I'll lose. There's see defeat, and that just means that the turn that won was the opponent's turn, but it wasn't very clear that that's what happened, and I think I know a way to how to make it clearer. So what we're going to do is introduce the concept of hands, player hands. So how that's going to work is there's another kind of stack, and it's called a private stack, and it means that a private stack, the top card is visible to its owner. And this is going to get slightly more complicated, but bear with me. I promise it's nothing too bad. You don't, and you'll be able to follow. So we're going to create some more stacks, and we're going to do this in the setup, code. And we need to create a stack per player. And the way to do anything per player, if you want to sort of go do something for every player in the game, you go for each player. Okay, and then we're going to type P and then start end. And P here is just going to be a way of referencing what player we're on, right? And that's going to become clear in a second. So we're going to make a private hand here, or private stack here, and that's going to be, we're going to say P dot hand, and we're just saying that hand is a property of P, and it's a private stack, and P is the player that we're currently operating on, because we're looping through all the players. We're going, so that it's going to, basically what this is going to do is it's going to do this in a loop twice, because we have 2 players. And the first way around the loop, P is going to be player 1, and the second time around the loop, P is going to be player 2. So each player, at the end of the loop, each player will have a hand. And it's not enough to say the hand is a property of this player. We had to actually specify its owner, because it's a private stack. And to do that, we say p.hand.owner_id, like that. And to be honest, it would be clearer if you didn't have to type ID here, but you do, and I'll change that. So we say owner ID, and single equals as opposed to double equals is an assignment. It's like X is 5, but we're here saying owner ID equals P. So we're saying the owner of hand is this player here. And in order to demonstrate that it's a hand, we're going to actually move a random card into it. Random color, draw top 1. No, not draw, sorry. We're into our player's hand. P.hand. So you can see that for each player, we are moving a random color card into their hand. So I've reloaded this, and you can see that now these sort of opponent and you lines make sense. This is where it places the opponent's private stacks. You can't see that, right? And this is where it places your private stacks. In your private stack you have 1 card, it's yellow, and in your opponent's stack they have 1 card, and we don't know what that is. So now this has to change a little bit, right? Because what's going to happen is these hands don't do anything. The game still runs from the draw pile, and we kind of don't know whose turn it is, because we don't know who's done something. So what we want to do is have maybe the player place things on the in-play pile from their hand rather than directly from the draw pile. So let's do that. So we have in our turn, instead of draw in play, instead of moving a card from the draw pile to the in-play stack, we want to say current player.hand in-play top 1. And it's that easy. So and there we go, and that's red. And you'll notice the problem here, because there's only each player only has one card, and they never get any more. So we can definitely deal with that by doing this. We can say, okay, at the end of every turn, we move from the draw pile to current player dot hand top 1. And now you see that it replenishes our hand from the draw pile. Oh, there we go, the player 1. But let's do that again. So we're going to place a purple, we get a cyan, and the opponent is going to place, oh no, come on, a blue. There we go, cool, yellow. So now I have cyan. I'm not going to win, but I get a purple. Let's see what the other person has. Oh, I got a cyan, and there you go. So what I want to do is demonstrate attributes. Lastly, so so the way we're going to do that is we just to show you what that looks like. We're going to say that so this isn't going to affect the game, but I just wanted to show you how it works. So we say all color cards have what do cards have? They have a hue, right? It's going to be H, or saturation, like it's color saturation. Okay, so say it matters in the game how saturated the color is, and you'll know what saturation is if you haven't done any computer graphics. But anyway, so let's restart this, and you can see that saturation is 0. It's added this field underneath here, and it says saturation 0. Now, what if we wanted each of these color cards? They all need a different saturation, right? What if red saturation is 4? This is how you do it, right? And what if blue saturation equals 1? Pops up there. And yellow's saturation equals 5. And cyan's saturation equals 10. Purple's saturation equals 5 times 5. In programming, when you do multiplication, you use the asterisk. You would expect it to be the x, but probably you want to use the x for other things, so we use asterisk for that. So this just means 5 multiplied by 5. So it's going to be 25. And then a magenta will leave as... No, but you can already see that if you leave... So if you leave this blank, then it'll just be equal to 0. But let's make it something interesting. Saturation equals 5 plus 5. So you can do that too. We can also do minus, right, or divide. But let's just do plus. This is going to be... Actually, no, plus 5 plus 10. This is going to be 15, because that would have been 10, and that would have matched cyan. So I'm just going to press refresh a bunch of times to get random ones, but magenta's 15, and that makes sense. Blue, I had to press refresh a bunch of times there. Blue is 1, and that's correct. Red is 4. Yellow is 5. Red is 4. Purple. So you can see that this all makes sense. You can also have other things. So it's I don't know, health. Right now color has health for some reason. Right, it just pops up underneath it. So there'll be a big long list. And that's what you can do with Papertoy. I hope you've enjoyed this introduction. This is just the beginning. I've been working on this for about a year now, and I have so much more planned for this. And the main thing I have planned, not only just improving the language so you can do more with it, but also making it so that you don't have to actually write any of it. You can do everything. The idea is you'll be able to do everything inside the editor here without ever leaving it. Designing games and playing games. It's with something similar to, if you ever use Scratch, maybe it'll be similar to that. Using blocks to represent logic rather than code. Something easier for people to understand so it's not so daunting. So if you found this a little bit like, oh, it's a bit daunting, I'm not a programmer, I don't understand this, I don't feel like I want to spend the time, then don't worry, because you won't have to do this. You'll be able to do it graphically, and and the idea is that it'll be very easy. So yeah, I hope you've enjoyed this, and until the next time when I have another update, it'll be goodbye. So thank you for watching.